All right, we're going to go ahead and look at example 7. We're going to sketch the graph of a function f that satisfies all of the following conditions. So it says the limit as x approaches 2 from the right is infinity, and the limit as x approaches 2 from the left is negative infinity. So I'm just going to go ahead and look at those two first. If I am approaching 2 from the right and from the left, and I'm going to an infinity, there is some form of an asymptote here. I just need to think about what kind it is. So if I'm coming to 2 from the right, this is my right-hand side, it's going to be going up. And if I'm coming to 2 from the left, I'm going to be going down. So that means there's going to be a vertical asymptote. So this right here is telling me there's a vertical asymptote. And the vertical asymptote is going to be at x equals 2. So I'm going to put that on there. And then it's always important that you guys label your vertical asymptotes. So this is x equals 2. And then I'm going to actually just make a little note of where everything is going. So this is telling me as you approach 2 from the right, my end behavior is going to infinity. So 2 from the right, I know I need to end going upward. Okay, and then 2 from the left, I need to be going to negative infinity, which means I need to be going downward. So I'm just making a little note about that. Moving on to the next thing. Oh, it says limit as x approaches plus or minus infinity. This is really telling me two limits. It's the limit as x approaches infinity of f of x equals 1, and it's also telling me my limit as x approaches negative infinity of f of x is equal to 1. Okay. Once again, this is a form of an asymptote. So this is saying as I look all the way to the right or towards greater x values, all the way to the right, I'm going to the number 1. And as I look towards the left, I'll be going to the number 1 as well. Okay, so that would be a horizontal asymptote at 1. And I would want to label that as well. And that's at y equals 1. And this is, like I said, horizontal asymptote. Horizontal asymptote at y equals 1. And then this last piece of information is just telling me I have a point. The point is negative 3, 0. Okay, so I'm going to go ahead and put that on there. I got negative 3, 0, so I have this point. Now, I'm going to connect my pieces of information. If I look kind of in this little area, I need to be going downward, and then I need to approach my horizontal asymptote. So I'm going to have something like this. Okay. And then over here, same thing. I got this arrow and I know I need to approach my horizontal asymptote, so I'd have something that looks like that. So there would be the sketch of the information provided. Then it says find a formula for this function that satisfies the conditions above. Okay. Well, I would just start with vertical asymptotes. I know I have one at x equals 2. Where do vertical asymptotes come from? Well, if I go back to my notes that we were talking about. Sorry, I don't have them filled in, but to find it said vertical asymptotes or removable discontinuities, holes, you set the denominator equal to 0. So our vertical asymptotes come from our denominator by setting it equal to 0. So if I go back to my problem here, where this would come would be from my denominator. And in order to get an answer of 2, okay, I would have x minus 2. Because when I set it equal to 0, I would get it equal to the number 2. Okay, then I would move on to horizontal asymptotes. Horizontal asymptotes we talked about earlier, and the way we get those is by looking at our end behavior, our limit as x goes to infinity. So we're going to come back to that one. Let's just talk about this next thing. We got negative 3, 0. What is negative 3, 0? That is an x-intercept. Those are also what we call our zeros. And where do zeros come from? Those come from our numerator. Okay, so in order to get an answer of negative 3 from our numerator, we would have had x plus 3. Okay. So vertical asymptotes and holes come from denominator. Zeros, roots, those are the same thing, just different words for them. Those come from our numerator. Now let's check out our horizontal asymptote. The way we check this, we would do our limit as x goes to infinity of x plus 3 all over x minus 2. And we should get an answer of 1. Okay, the way we do this is, remember we say what's our biggest degree in our denominator, and in this case it's x. So I'm going to divide out everybody or factor out an x. So we have our limit as x approaches infinity. I would have x in front and I would reduce. I'd have 1 plus 3 over x all over. Taking out an x again, so I'd have 1 minus 2 over x. Our x's would cancel. And then I would think about taking the limit as x approaches infinity, so plugging in a very large number for x. If I have some number over an x to a degree, that will go to 0. and that will approach 0. So when I do that, I will have 1 over 1, which is 1. And so my horizontal asymptote checks out. So this would be my formula for example 7.